Hey everyone, notes 3.5 are in parabolas in factored form. And this chart that we created, we did it together in class. So we're just going to skip down to this section right here where we're talking about factored form. So this is another way that you will see the equation of a parabola. So we've learned that you could see it in the format y equals ax squared plus bx plus c. This is standard form, or we've also learned vertex form, y equals x minus h squared plus k. Now we've got one new form, which is called factored form. And factored form is really useful to us when we're trying to find roots or x-intercepts, because our roots or our x-intercepts are literally just going to be these values right here. And we've discovered that when we did this chart right here. Okay, so our roots or our x-intercepts will always occur where x is equal to r or x equals s. These are our roots, but don't forget our as intercepts we have to write r0 and s0. Okay, now just a reminder, when we have any kind of a parabola, so like let's say our parabola looks like this, I'm just going to randomly draw in a parabola right here. Here are our roots. Just a reminder, our axis of symmetry will always occur right halfway in between our roots. So it's always going to be the average of our roots. So to find the axis of symmetry when we have our equation in factored form, we just add the two roots together and divide by 2. That's how you find the average of two numbers. And then our vertex will always occur on the axis of symmetry. So it's always going to be the axis of symmetry combined with the optimal value, but the optimal value we only figure out after we plug in the axis of symmetry into the equation of the parabola. And then lastly, the y-intercept will always happen when x is 0, always. The y-intercept, no matter where your graph is, your y-intercept's x value is always going to be 0. So we always have to plug in 0 into the equation of the parabola. Let's apply this. Let's see how this is going to work. Okay, so in our first example right here, we have this equation written out in factored form. We got a times x minus r times x minus s. And here we can say that a is 1, r is positive 3, and that s is negative 5. Because remember, right here, to get this to be a minus 3, it has to be a positive 3 because of this minus sign right here. But to make this a positive 5 right here, we have to do x minus negative 5. This turns into a plus sign, which means that the s is negative 5. So just a reminder that r and s are always the opposite sign of whatever you see here, just like h in vertex form is always the opposite sign. Okay, so here our roots will be at x equals 3. We get that from this value right here, and x equals negative 5. We get that from this value here, or from the r and the s. Okay, now to find the axis of symmetry, we have to average our roots together. So I'm going to average 3 and negative 5 together. Now 3 plus negative 5 really means 3 minus 5, right? And 3 minus 5 is negative 2. Divide that by 2, I get negative 1. So the equation for my axis of symmetry is x equals negative 1. Let's make this clear that this is a negative 1. Now to find the vertex, so actually let's graph this stuff out right here. So we know that our roots will be at 3 and at negative 5. Okay, so we know those are 2 points in our graph, but we also know that we are going to have this line right here is going to separate, or sorry, not separate, cut my parabola down the middle. And I know that my vertex is going to occur somewhere on this line. Where on this line is this vertex going to occur? I have to plug in negative 1 into the equation of my parabola right here. So I'm going to start by writing out y equals x minus 3 times x plus 5, sorry. But every time I see an x, I'm going to replace it with the number negative 1. So right here, negative 1 minus 3 is negative 4. Negative 1 plus 5 is positive 4. Negative 4 times positive 4 is negative 16. So I know my vertex is going to occur at negative 1, negative 16. And I apologize because this right here clearly is not going to be large enough of a graph. So we're just going to put it like all the way down here. I'll extend this some more. And we can say that our vertex will be somewhere maybe down here. Okay. And then lastly, we have our y-intercept, and the y-intercept happens on the y-axis. That's always when x is equal to 0. So I'm going to do the exact same thing I did here, except instead of replacing the x with negative 1, this time I'm going to replace the x with a 0. So here I'm going to say 0 minus 3 and then 0 plus 5. Well, 0 minus 3 is negative 3. 0 plus 5 is positive 5. So here, this would be at negative 15. But as a coordinate, remember the x value is always 0 on the y-intercept. So it'd be 0, negative 15. So I will have a point right here, which is 0, negative 15. I also know there's a point on the other side at negative 15, one to the left of the axis of symmetry, because it's literally an axis of symmetry, which means that it is symmetrical. And then I can just connect all of these points right here, and this will be my parabola. Try to make it as smooth as you can. And don't forget to write the equation on your parabola. All right, in our next one, we have an a value here is going to be negative 0.3, which tells us that our parabola is going to open down. The r value is positive 4 here, and the s value is negative 4 right here, which means that our roots are going to be at positive 4 and negative 4. To find the axis of symmetry, I'm just going to average those two values. So I'm going to do 4 plus negative 4 divided by 2. But just a reminder, 4 plus negative 4 means 4 minus 4. 4 minus 4 is 0. 0 divided by 2 is 0. Your value for your axis of symmetry better be halfway between your roots. Otherwise, it just doesn't make sense. So let's go ahead and graph out our roots. We've got negative 4 and positive 4. And then we also know that we are going to have our axis of symmetry is going to happen exactly on the y-axis because it's at x equals 0. But what is the vertex going to actually be? We write down the equation of the parabola. We take the x value that we got here and plug it in every time we see an x into this equation right here. So I get 0 minus 4, 0 plus 4 right here. So then here I get y equals negative 0.3 times 0 minus 4 is negative 4. 0 plus 4 is positive 4. And then I can just type that into my calculator and see what I get. So I would type in negative 0.3 times negative 4 times 4, and I would end up getting 4.8 right here. So that means that my vertex would occur at 0, 4.8. Now, let's go ahead and graph that out. So that would be approximately right here. And if you look and see, if I were to connect these dots right here, I can see for sure that my parabola is going to open down. So this is some good news right here. And then lastly, the y-intercept, remember, always occurs when x is 0. But we've already figured out what happens when x is 0. We found out that y would be 4.8. So it's at the same spot, because if the axis of symmetry is on the y-axis, then it's also going to be the y-intercept. And then we can just connect those dots. And this is our parabola. And always remember to label your equation. Okay? All right, people. For this next one, I'm going to have you pause every once in a while and try to do some things on your own, just to give yourselves a chance to actually try this on your own. As I ask you to pause, if you get things wrong, that's totally okay. That's how you learn. That's like, mistakes are needed to be able to learn. But write down little notes on the side so you can ask me next time you see me in class if you have any questions about any of it. Okay, so here our A value, our R value, and our S value. Go ahead, press pause, try to write it down, and then come back to me to see how you did. So you should get A is negative 1/2, R is 1, and S is 7. R and S are both positives because they're always the opposite sign of whatever we have here. The fact that A is negative 1/2 means that our parabola is going to open down. Please go ahead and write out your roots. So your roots should be x equals 1 and x equals 7, or you could write it out as 1, 7 in these set brackets. Okay, it's really important that you don't write it out like this because this means x is 1 and y is 7, which is not the same thing. Let's go ahead and graph out our roots. Okay, now go ahead and try to find the axis of symmetry. So just a reminder, you just add up your roots together and then divide by 2, find the average of those two values. So your axis of symmetry will occur when x is equal to 4. And when you draw it in, it needs to be right in the middle halfway between your two roots, which it is. Okay, and then our vertex right here would have to be when x is 4. So I have to use my equation right here. So y equals negative 1/2 times x minus 1 times x minus 7. So every time I see an x, I'm going to replace it with 4. So go ahead and replace it with 4 and then evaluate and see if you get the same thing I do. Press pause and try it, please. So you could get 9/2 or 4.5 or 4.5. All of these answers are perfectly acceptable. So your vertex will occur at 4, 4.5. Okay, and then lastly, let's do our y-intercept. Now our y-intercept will always happen when x is 0. So I'm going to do the same thing, but I'm going to replace the x with 0. Pause, try it on your own, see how you do. So you should get -7/2 or -3.5. So our y-intercept is at 0, -3.5. I'll go ahead and graph that point out right here. And I'm also going to graph out the symmetrical point on the other side of my axis of symmetry that lines up with this. So I know that this is 4 steps away from the axis of symmetry. So I'm going to go another 4 steps. And I know that when x is 8, y would also have to be -3.5 because it is symmetrical. Go ahead and connect those points together right here. Make your nice smooth parabola. Label the equation on your parabola, and that's how you graph out parabolas in factored form.